Okay, so let's continue our discussion. So Galileo Galilei was the first one to hypothesize that if you have a given or you have two given objects with different geometric shape, different composition, different density, in other words, different weights and shape. If we assume that the Earth has no air resistance, then these two objects will fall at the same rate. No? So they will reach the Earth. No? If this is in free fall, this will fall at the same time. Okay? And then this acceleration due to gravity can be measured as constant. So, with regards to the previous topic, we have the horizontal motion. At this subtopic, we will now discuss the vertical motion. So, we are translating in the vertical axis. So, the acceleration due to gravity, which is a sub y, no, in the notation of acceleration in the vertical axis, which is equal to negative g, and the g is equal to negative 9.8 meter per second squared. So take note of this. We will utilize this for our formulations. We could simplify, or we could tweak, no, the given kinematic equations that we have discussed earlier by changing the variables of x, no, horizontal, into y, which is vertical translation. So this is the same thing as the previous equations, but we just change things up, no, from x to y. So let's see, we have an example here. So let's say we have a stone thrown from the top of the building, and it is given its initial velocity of 20 meters per second straight thrown upward, and then the stone is launched 50 meters above the ground, and the stone just misses the edge of the roof on its way down. So find, determine the determine the time at which the stone reaches its maximum height. Ayan. So this is the ball now initially, and it has a throw velocity of 20 meters per second. So we have already an initial velocity. Sorry, this should be in y coordinate. So we have Vyi, that is equal to 20 meter per second. Now, we can also say here, actually, that this is our reference horizon. So this point should be 0. Everything above is positive. Everything below is negative. So we can say that the initial position is 0 as well. Now, what can we know, or how do we know the time at which the stone reaches its maximum height? So what we could use here is depending on what is given to us. So what do we know here? At which point na lang, no? At which point is this ball at its maximum height? So at this point, diba? So what could be the velocity at this point? Okay, so let's call this the final velocity, Vyf. Okay, so at this point, at a brief moment, the velocity will be 0. Okay, so this will be 0 at this moment, at this maximum height. Therefore, we have a relationship of this initial position, velocities given. So what should be the equation that we should use? Okay, so don't forget as well, we have the gravity. Okay, let's list down the givens. So the given here, Vyi, we have 20 meters per second. So this is positive again, no? Since this is upward, no? Pag upward positive, kapag downward negative. And then we have the height, which is 50 meters. And then the final velocity, well, at this specific scenario only, no? 0 meter per second, and the AY, which is the gravity, okay, which is equal to negative 9.8 meter per second squared. So the relationship of these given variables, we can solve for the maximum height. So in reference only to this y is equal to 0 reference point. No? So this distance between these two, you can solve this using this formula. So we have byf is equal to byi is equal to, plus ay times time. Okay? You can utilize this, right? So what is the time? That's what we're looking for. We have a given acceleration due to gravity. The initial is given. The final velocity is given. We can solve for the time. Okay, so let's solve for the time first. Manipulate this. First, we have byf minus byi via the transposition, no? And then over ay. So ay and then equals to time. So therefore the time is equal to, so the final velocity is 0 minus the initial velocity 20 meters per second over the acceleration due to gravity, which is negative 9.8 meter per second squared. So therefore the time is equal to, so what's the time? We have negative, mode 1, negative 20 over 9.8 or negative 9.8. So the time will become positive. So this will be 2.04. So 2.04 seconds for it to reach the top. Okay, let's find another variable here. So find the maximum height of the stone. So to find the maximum height of the stone, what is this final position? So the same given now. So we want to find this yf. So to find the yf, this will be equal to yi using the formula plus we have b byi t, okay, plus we have ay and then t squared over 2. So we have already a given of initial position, initial velocity. We already saw the time at this point. No? So the time at this point is 2.04 seconds. Okay, so we already solved this one. We already solved for the, or we haven't given the acceleration due to gravity. So yf will be equal to, so this is equal to 0. We solve, this is given. Plus byi, which is 20 meter per second, multiplied by 2.04 seconds, plus we have 9.80 meter per second squared, multiplied by 2.04 seconds. Sorry, it's not page here. So this will be equal to, let's see, no? So we have 20 times 2.04 plus 9.8 times 2.04 squared over 2. So this will be 61. Oh, it should be negative. We forgot the negative sign, no? It should be negative here. Don't forget the negative sign. Oh, 1. So this should be negative. Therefore, the maximum height is 20.41. So 20.41 meters. So what does this mean? Meaning, if our reference point is this, which is 0, then above that, no, so if this is positive, therefore above that, 20.41 meters. Okay, so until this point. Yes, this length here. Okay, determine the velocity of the stone when it returns to the height from which it was thrown. Okay, so determine the velocity at the point at which it was thrown. So it will return also after it was thrown upward, it will go downward, and it will reach the same initial points, no, of positions. Okay, therefore we could say here that we have the relationship of two variables. So we have what we have here. Now we do not know the time here. We do not know the time here. So let's have an equation that does not have a time, which is this. So we have byf squared that is equal to byi squared plus 2a y and then yf minus yi. So what are the givens here? Given the initial velocity is given, The acceleration due to gravity is given. And then the final, no? So what is the final here? So the final position here is, no, assuming that this is the reference, no? Which is 0, then therefore YF and YI is equal to 0. So we have given 2 points. So VYF squared is equal to VYI squared plus, we will substitute the value, no? Sorry. So 20 meters per second squared plus 2 times AY. So AY here is negative 9.8. And then multiplied, sorry guys, it does not fit. So multiplied by 0 minus 0. Okay, then the units, no? So it is not necessary to put this term anymore since this is the 0. Therefore, VYF, or the final velocity, is equal to the square root of 20 meters per second squared. So the square root and square will cancel out. Therefore, the answer should be 20 meters per second. Is that correct? Actually, it should be positive or negative. Although, at this scenario, as we can see, guys, what is the direction of your ball as it goes from here to here? Ano? So, as you can see, this is downward. So, therefore, the sign should be negative. So, we should choose a sign of negative here. Therefore, the final velocity is equal to negative 20 meters per second. Okay, downwards velocity is negative, upward is positive. Okay, find the velocity and position of the stone at t is equal to 5 seconds. So how do we do this? We have here given time, no? So we know the time somewhere, no? Somewhere here, siguro, no? Maybe here. So let's just write this here, maybe somewhere here. We have t is equal to 5 seconds. Now, to figure out the velocity and the position at this point, we have two equations for that. So let's first solve the velocity. So we have VYF. So actually, we have two equations. But since we have a given time, we will use the equation that has time minutes formulation. So we have VYF is equal to VYI plus AY times T. So the same equation we used earlier. So we have already a given initial velocity here. Okay. And then acceleration, and then we have a given time. So therefore the final velocity at 5 seconds, we have 20 plus negative 9.80. Always put the sign, guys. And then times time, which is 5 seconds. So the final velocity will be, okay, so what is this? So this is 20 minus or plus, say plus, no? Negative 9.8 times 5. The final velocity is negative 29 meters per second. So what does this mean? So if your velocity is negative, then its direction is going down. So your VYF, so the velocity here is negative. It seems it is going down. And then to find the position, so we have YF. So again, we have a given time, so we will utilize an equation that has time. So we have YI plus we have 1/2. Also not 1/2. Actually, we could also use that. We can actually use that since we have already a given velocity. But I will use a different one. DIYT plus 1/2 AY t squared. So given, okay, this is also given, time is given, acceleration due to gravity is also given. So the initial position is 0, initial velocity, time is 5, plus 1/2, negative gravity, acceleration, and then t, so 5.0 seconds, squared. Don't forget the squared. So the final position, so this will become negative, as you can see. So we have 20 times 5 plus 1 over 2 times negative 9.8 times 5 squared. So the answer should be negative 22.5 meters. So what does this mean? What does this mean? Why is it negative? So the negative sign means that it is going down. So the direction of your measurement of position should be downward. So if this is your yi, which is equal to 0, therefore yf, for the final position, is equal to negative 22.5. So this length here is your yf meters. But if you want to figure out what is the height with a relative distance to the ground, you can say that this is 50 plus negative 22.5. So this will be 27.5, no? If it is in reference to the ground, since this is 50 meters, this thing here, no? This height. Okay, so that will be all for this video. Thank you guys.